Hello everyone, this time we are going to discuss uniform circular motion and centripetal and centrifugal forces in this session. So let us begin. The uniform circular motion, what is it? How to define it? When a particle, an object, moves with a constant speed in a circular motion. Constant speed, that means the speed remains uniform. When a particle moves with a constant speed in a circular path, then its motion is said to be uniform circular motion. Now, as the speed remains constant, that means what? That means the object travels equal distances in equal time intervals. That is how it remains in uniform motion. But what happens as the motion is circular, the particle has to change its direction at each and every point of a time. For example, if a particle is on a linear path, then it does not have to change its direction. Suppose a particle is moving on a rectangular path, that means it has to change its direction 4 times at the 4 corners. Now suppose there is a pentagonal path, then what? The particle has to change direction 5 times. From this we can understand that if you go on increasing the number of sides in a polygon, then the number of turns the particle has to take also increases. But in case of a circle, there are n number of sides, that means the particle has to change n number of times the direction of the motion. That means what? The particle is moving with a uniform speed, but the direction changes at each and every point of time. That means the velocity of the object is also changing. So we can say that there is a uniform motion, a uniform speed, but there is a change in velocity. Now if there is a change in velocity because of a change in direction, we can say that there is a change in the acceleration. Hence, you can say that uniform circular motion is an accelerated motion. Now, how to find the direction of the particle that is moving on a circular path? For defining the direction of the particle moving on a circular path, let us first define the directions, the north, south, east and west. And let us say there is a circular motion like this in the anti-clockwise direction, and the particle is moving from point A to point B to point C to point D and then again to point A. In this way, it is moving in an anti-clockwise direction. Now, as we know, the direction of a particle that is moving on a circular path can be found out by drawing a tangent at that point. So, at point A, if we draw a tangent, then the direction of the particle will be in this way. That means it is moving in the north direction. Now similarly, if we draw a tangent at the point B, we can say that the direction of the particle will be in west direction. Similarly, if we draw a tangent at point C, we can say that the tangent is like this, so the direction of the particle is in south. And at the point D, again if we draw a tangent, that means the particle's direction will be in the east. So the particle changes direction at each and every point of time on the circular motion. That means the speed remains the same, but the velocity is variable, and that is how it is an accelerated motion. Now, what is the basic difference between the uniform circular motion and uniform linear motion? Well, I have already said that in a uniform linear motion, there is no change in the direction. That means the velocity is not changing and hence there will be zero acceleration. But in case of a uniform circular motion, the velocity changes at each and every point of time and hence the acceleration also changes. This is the basic difference. Okay, now we know that if an object is performing a linear motion, then if we want to change the direction of that motion, we have to apply a force, right? Whereas in case of an object performing a circular motion, it is changing its direction at each and every point of time. What does that mean? Does it mean that a force must be acting on that particle at each and every point of time, right? That is the only logical explanation. So if an object needs to change its direction, that means a force has to act upon it to change the direction, right? So in case of a circular motion, a force must be acting at each and every point of time on that object. That force, we are going to name it as the centripetal force. Centripetal force literally means that the force that seeks its center, or center seeking force. The force which is acting towards the center of the circular path is known as the centripetal force. For example, if an object is like this, performing an, let us say, anti-clockwise circular motion, if it is at A, then B, then C, and then D, then if it is at point A, let this be the center, the object is pulled towards the center like this. If it is at B, the object is pulled at center like this. If it is at C, if it is at D, then the object at each and every point of time is pulled towards the center by a force, and that is known as the centripetal force or center seeking force. There are many examples of, let us say, an atom in which the electrons are moving around the nucleus in a circular path. This is an example of a centripetal force, where the electrons are pulled towards the center by the force of the nucleus, that is known as electrostatic force. And also a planet that is moving around the sun in a circular path in its orbit, they are moving around the sun with the gravitational force which pulls the planets towards the sun, that is the center of the motion. Similarly, the moon, which is revolving around the earth, that also is being pulled towards the center, that is towards the earth. Then a simple example, when a stone is tied with a thread, with a string, and you are whirling it in a circular path, then the tension created in the string is also towards the center, that means towards the hand that is holding the string while rotating the stone. So these are the examples of centripetal force in acting on a body which is in a circular path. And if we recall, then this is a type of dynamic equilibrium that we have already gone through in one of the sessions. Now, if there is a force acting on an object which is acting seeking towards the center, then to keep the object in dynamic equilibrium, there must be a force which is acting away from the center also. So if the force acting towards the center is known as centripetal force, then an equal amount of force would also be acting on an object in the opposite direction, and that is known as centrifugal force. Now keep this in mind, that the centrifugal force is not the force of reaction, because action and reaction are not acting on the same object. They are always acting on two different objects, remember? So these forces are acting on a single object, that is why this is not a case of action and reaction forces. So now, if the force acting towards the central is centripetal force, then the force acting away from the center is known as the centrifugal force. Now it is considered that centrifugal force is not a real force, that means it is a fictitious force. Why? Because it is assumed by an observer that is moving in circular path along with the body. Now to understand this, let me take an example of a merry-go-round. Let us say that there is a merry-go-round and this is the center of the merry-go-round, and there are two observers in this case, a person M which is standing away from the merry-go-round, that is on the ground, and a person A which is standing at the center of the merry-go-round, and there is an object P at the boundary of the merry-go-round. Now let us first make it clear that when the merry-go-round will go in a circular motion, the person standing at A will also be in circular motion along with the merry-go-round. Is this clear? Okay, so now this object P is at this point, the person A is, let us be specific, the object, and the person right now is at this position. Now the merry-go-round starts rotating. So after a certain period of time, let us say the object P comes to this point, and let me call it as P dash, and the person at A comes at this point, and let us call it the position A dash. Initially, the object P was at this much distance from point A, the observer at A, and the second time the object and the distance between the observer still remains the same, right? Okay, after some more time, let us say the object is at this position, and let me call it P double dash, and the observer will be at this point, let us call it A double dash. Now again the position of the particle and the observer are in stationary position. That means the observer will think that the point P, the particle at P, is remaining stationary throughout the motion, right? The point P, the particle at point P, is always in front of the observer at point A. That means he thinks that the particle at P is not going anywhere, it is always in stationary position in front of him. But for the person standing at M, first the particle was at P, then the object came at P double dash, then it came at P dash, P double dash, like this. It means for the person standing at point M, the particle is changing the places. But for the person that is standing at the center of the merry-go-round, the position of the particle does not change, it remains the same. Now for the person that is standing at the point M, the ball is moving in a circular path because he is observing it because of the force, the tension force that is produced in the string, and that is providing the centripetal force for that particle to move at different positions in a circular path. But for the person standing at point A, the object remains stationary in front of him. Now what could be the reason for this, right? The person at A has to explain this. So in his case, he is assuming two forces. The first one, that is the tension produced in the string, that is pulling the object towards the center, but the object is not coming towards the center, it is remaining stationary. That means there must be another force that is pulling it away from the center, and that force assumed is the centrifugal force. That force assumed by the person at A is the centrifugal force. There must be a logical reasoning why the object remains in front of him, why the object is not going towards the center, right? Because there is a force of tension in the string attached with the point A and P. So the centrifugal force acts on the object which is away from the center, and as the two forces are equal in magnitudes and opposite in direction, that is why the total force acting on the ball is zero, and that is why it remains stationary for the observer standing at A. This explains a lot, right? Now let us take one case where the tension in the string, the force, is suddenly ceasing to act. That means suddenly it stops. The force that is acting towards the center suddenly stops. Then what will happen in this merry-go-round? The forces are in balanced condition right now. That means the inward force and outward force are equal in magnitude. That is why the particle at P remains stationary. Now let us say the force acting towards the center ceases, or it stops to act. That means the inward force is now gone. So what remains is the outward force, which is equal in magnitude but opposite in direction. Then what will happen? The person who is standing at the position M, as we know, when a particle is suddenly released from a circular moving path, then what happens? It moves towards the tangential direction like this, right? So the person that is standing at M will see the particle moving in this direction, that is tangential, and it will be observing the different points of the particle like this. But the person who is standing at point A will see the particle as if it is moving away from the observer in a straight line. So the centrifugal force is not a real force, it is a fictitious force. The only force involved here is the force of tension in the string that is acting towards the center, because the observer at the point A will always see that the ball remains in front of him only, but it is moving away from him in a radial direction. It is moving away from him in a radial direction because of the centrifugal force. So a force which really does not exist, but it is considered, or it is described to understand a certain situation, that is a fictitious force. And in our case, the centrifugal force is the fictitious force. The only force that is acting is the tension in the string towards the center, that is the centripetal force. So this is it about the uniform circular motion, the centripetal and the centrifugal forces. If you have any doubt, then please mention it in the comments. Thank you for watching, and subscribe to the channel if you have still not subscribed for regular updates and regular sessions. And we'll meet next time. Till then, bye.